So now we've looked at our theorems for our special right triangles. Remember, these are only right triangles where either there are acute angles of 45 degrees for each acute angle or 30 degrees and 60 degrees for the two acute angles. So right triangles in general do not have this relationship. It's just these special right triangles. That really needs to be emphasized. What we're going to look at in this particular video are the situations where we have the 45, 45, 90 triangles. Remember that our relationship is that if we say we have a leg of length L, that the other leg will also have a length of L, and the hypotenuse will have a length of L times the square root of 2. So in our particular case, in this first situation, we have a 45-degree angle in this acute angle. Here is a right angle. This one's not labeled, but the sum of the angle measures in any triangle is 90 degrees plus those two. Okay, we have that 90-degree angle. So each of these would have to be numbers whose sum then would be 45 degrees plus 45 degrees, making the total 180 degrees. So here are our legs. If 8 centimeters takes the place of L in this ratio, then A is also equal to L. Those two are the same. So we would know that A is 8 centimeters. And then B would take the place of L times the square root of 2. So if I'm writing this out, L is 8 centimeters, the length of a leg. So B would be L, 8 centimeters, times the square root of 2. So that would be 8 times the square root of 2 centimeters. Don't forget your labels if our values do have units attached to them. B gives us another situation. Here, I know I have a right angle. These two angles are labeled as being congruent. Well, that's 90 degrees out of the 180 degree total. So those two have a sum of 180 degrees minus the 90 degrees. In other words, those two have a sum of 90 degrees as well. And if they're congruent, then each one of those is 45 degrees. Again, those theorems only apply to special right triangles, so we need to make sure before we try to use those that we do actually have one of those right triangles. Now, in this case, okay, we're still going with this idea that we have this ratio of sides. That's L for the length of the two legs, and then the hypotenuse is L times the square root of 2. In this case, we know that the hypotenuse is 10 meters. So that means L times the square root of 2 is 10 meters. To figure out L, we would divide both sides by the square root of 2. Now, at that point, we could leave our value that way, but just as we simplified square roots by factoring out squares from the radicand, the number under the square root symbol, another way of simplifying square roots is if I have a square root in the denominator, we do what's called rationalizing the denominator. Anytime I multiply a square root times itself, I get the number that's under the square root symbol. That's what a square root is. A number that times itself gives me another value. So if I were to multiply both the numerator and denominator of this fraction by the square root of 2, in the numerator, 10 times the square root of 2, but in the denominator, square root of 2 times the square root of 2 is just 2. That's what a square root is. If I multiply the square root of 2 times itself, it means I get 2. And notice then, with these two values that are outside the square root, I can simplify that to be 5 times the square root of 2. 10 divided by 2 is 5. And that would be in meters. So, I now know that L is 5 times the square root of 2 meters, and that represents the lengths of each of these two legs. So I would know that M is going to be 5 times the square root of 2 meters, and N is going to be 5 times the square root of 2 meters. Those are the examples for the 45, 45, 90 triangles.